Hello, everybody, and welcome to another Microsoft Reactor live stream. So it's great to have you here. I'm just going to move this off the stream for a second. So thank you for coming. It's been a while. I've been super busy with advocacy, but it's good to be back with another episode. I'm not feeling 100% today, but I didn't want to let you down. So we've got a really nice laid out episode of Learn Go with Liam. So let's just get straight into it. If you want to, pop in the chat, say hello where you're coming from or where you're viewing from. We'll have a conversation and, of course, always put in your questions and whatnot. So let me add my slides to the screen. And you know what? Let's just go straight into it. Cool. So today's episode is called A RESTful Time. And that is because we're going to be starting to look at APIs and data transmission within Go. So before we get started, please do take a moment to have a little read of this. Just read the bullet points on the right-hand side. So, please be kind, please be respectful, please just ask great questions, and we're all here to learn. So everyone's here for the same reason. So I'll leave that one up for just a second. But whilst I'm doing that, I will just say it's been a pretty turmoil couple of weeks in the tech industry. I think everybody's kind of aware of a lot of redundancies that have been made and sort of layoffs, and it's not nice. So somebody has put together a lovely blog on the Microsoft Tech community site. And if you go to aka.ms/get connected now, then you'll be able to go to this and you can look at exploring career paths within Microsoft and the tech industry, how you can join a talent community, how you can get prepared through Microsoft Learn, and how you can update your LinkedIn profile to stand out to recruiters and to get your next job. So hopefully you haven't been affected, but if you have, this is a fantastic way to get back on the horse and really get back at it, because it's a fantastic industry to be in, and we are also lucky to be working in it. So what's on the agenda today? And by the way, if you see me looking across all different things, I've kind of got lots of screens going on. It's a different setup, as you've probably noticed. I'm usually in office, but today I'm at home. But yeah, what's on the agenda today? We're going to talk a little bit about me, what I do, and where I've come from. We've got a Cloud Skills Challenge for this series. We're going to look at a bit of a recap, what we did last time in the last episode. We're going to look at data types. So we're going to get into the bulk of today's episode with data types, data structures, and then I'm going to go through a little bit of code, walk you through some first-hand API writing, which I've done. It's going to be a bit of fun. It's nothing too serious, but hopefully it'll help you understand some of the theory that we go through in today's episode. So who am I? What do I do? My name is Liam Hampton, and I'm the Microsoft Regional Cloud Advocate based out of Microsoft Reactor here in London in the UK. So if you're joining from abroad, if you're joining from a different country, put it in the chat and let me know. So what I do as a cloud advocate, I help upskill the community. I help work with others in the community to help build their community. So we're talking about different leaders of community groups or meetup groups. I run the Microsoft or the Reactor London meetup group in the Microsoft Reactor office in London, which is fantastic. We've got a really strong community. So of course, if you've seen us or seen this episode on Meetup, I run the in-person side of that as well. And I go and talk at conferences, and I work with engineering teams within Microsoft to help build the brilliant products that we help put out that you use every day. I'm also an All-Zero ambassador because I think about security and I like security a lot. It's one of those conversations I have with developers. Being a developer or having a background in engineering myself, which is difficult, security is always a really, really hard topic to understand and think about as a developer. I'm a Dev Network Advisory Board member, so I help shape the community and I help shape conferences and hackathons and how they're judged and how we run them. I write Go code. Like I said, I was an engineer at IBM for a couple of years ago before I became an advocate, and that's sort of where I got into writing Go, and I like to travel the world. That's just a little bit about me. So please throw it in the chat. Tell me what you're doing and tell me where you're from. So with all of my episodes, I have two learning goals, always. Today's learning goals is going to understand the basic data types used in Go. So, strings, integers, floats, etc. And then the other one is to understand how to work with data returned from an API. So the practical side of it. So hopefully you can put two and two together and look at the data structures versus the actual code that we look at as well today. Gone too quickly. So before we go, everything I do today, you can do too. We're not going to be using Azure again today, but it will come up in future, either not the next episode or maybe the continuation of Learn Go with Liam. But everything I do is free. You can do this yourself. If you're a student, please sign up for a Azure account. You get some free credits and some really cool add-ons which you can use, especially with GitHub as well. But if you go to aka.ms/A4S, then you can get yourself a free trial account. And if you're a professional, aka not a student, you can go to azure.microsoft.com/free, and you can also get a trial account with, I think, $200 of credit, which you use over 30 days, and you can get access to a whole bunch of different services in Azure. It's really, really cool. And everything which we go through in Learn Go with Liam, you can then deploy to the cloud as well. You can deploy into Azure really quite simply. And I will be showing you how to do that. Even if it's not in the next episode, if I run out of time, it will be in future ones. And of course, I've done it before with a lot of all of my other episodes, which I've done. All of my content is written in Go, regardless whether in Azure or not. Cool. Where are we then? So let's go into today's episode. So today we're at episode 3. So thank you. If you've not joined from the previous episodes, then of course we do have, it's in the playlist in YouTube, or you can visit the events page or the series page for this series, and you will be able to see all the other episodes which I have done for you. But today we're going to be working with structs and JSON objects and how to manage that data and looking at the different data types in Go. So I know I haven't really touched on them yet, and it's with good reason, because it kind of is quite cohesive in this episode to be talking about them all. So, of course, we've got the Cloud Skills Challenge, so I'll give you a second to scan that one and have a go at that. Please do go on with it, have a little go, see what it's like to work with Go in Microsoft Learn. Everything which I cover is also going to be covered in these Learn modules, just in a little bit of a more cohesive way where I'm able to put it forward for you. And of course, please do give it a go. So a recap. What did we do in the last episode? Well, we looked at imports, so how you can import different packages, whether it's your own package, whether it is third-party packages, or whether you're using the standard library in Go in your code. We looked at functions with the values, so whether it is a single return value function, whether it doesn't return any values at all, or multiple return values, and how you can work with those, ignoring values when you call a function, and so forth. So that was a pretty comprehensive episode. I think I spent quite a lot of time talking in that one as well, but I will try not to do the same today and get a little bit more hands-on. We also looked at some testing. So we looked at the red, amber, green. So where you write a test, have it fail, you write enough code for the test to pass, which is amber, and then you write, well, you don't write any more code, you refactor your code to be more sort of better code, basically, the green dot. Then at the end, we created a web server. Admittedly, I ran out of time, but I did manage to get a web server written, which was just a simple sort of doing some basic arithmetic with a math function, which we're going to return to today. And I will show you, well, we probably won't touch it, but I'll show you just to jog your memory. And that's kind of where we got up to last time. And like I said, today, I just wanted to run through how you can now call an API. So we've got a server, and Go is brilliant for middleware. It's brilliant for web servers, and it's super performant. So we're going to dig into it. So let's start with data types. What kind of data types do we get in Go? Now, there's 4 main ones. We've got Booleans, we have got integers, we have got floating point numbers, and strings. Now, with this code on the screen, you can see the very first one is a bool, and this is just a number of ways. So in the code snippets which I give you in these slides, there's just a number of different ways of how you can assign variables, whether it is with a variable like the keyword var, whether it isn't the keyword var with the data type, which would be var a bool. So the variable a is a sort of a Boolean at this point, and with an equals. Or there's another really cool one, which is just using a colon and an equal sign, which gives you the data type and the value all in one line. But I'll show you that shortly. Back to what we were talking about, the different types of data which we can have. You've got Booleans, which is var a, var b, the integer, var c, floating, and var d is a string. And as you can see at the bottom, the outputs when you want to print them with the print lines is true, phi 3.14, which is pi, if anybody didn't guess that already. And you've got hi at the bottom, which is a string. So what about signed integers? Signed integers are interesting, okay? And they're interesting because it's all about memory management at this point. So strings was really simple, right? We can throw that one away. Integers are a little bit more complicated because these can store both positive and negative values. So a signed integer is 500 or minus 4,500. And equally, you print them out at the bottom, would be 500 or minus 4,500. But there are 5 key types. You've got int, You've got int 8, you've got int 16, int 32, and int 64. So if you've ever looked at a one of those tables where it's just doubling each time, it is the same with this with memory. Okay, so it's all memory management with 8-bit bytes, 8, 16, 32, 64, and that's 1 byte, 2 byte, 4 byte, 8 bytes, and etc. But this is dependent on your platform. Okay, so if you were just to write int as your variable, then it would depend as whether you're running a 32-bit system or a 64-bit system would be the default as to which you then use. But this is really sort of used when it comes to managing your memory and making sure you've got a really performant bit of code. So you wouldn't use int 64 with a really small integer or not all value, right? It's just not worth it. It's a waste of memory at that point. So usually you just put int and let your compiler do or figure it out for you. But then you've got the flip side of it. We've got unsigned integers, which can only store non-negative values. That's non-negative, so I could have really just written positive values at that point. But that's either 500 or 4,500. Okay, now, again, it's the same as before. There are 5 key types. So you've got uint, which is going to depend on your platform. Again, you can just leave that, and I realize I think in the code I haven't put uint, I've just put int. But again, you declare it with uint, 8, 16, 32, 64, the same 8 bits or bytes table that you'd use, doubling each time. And again, you'd use it depending on what you're trying to do, whether you want performant code, whether you don't want to waste memory. More often than not, you'll literally just see int. You rarely see uint, or at least I rarely see uint unless it's something to do with a compiler or files or something deep down in your system that people are sort of playing with at that point. Memory management, always thinking about it, and security. What's next? We've got floats. So floats are really interesting because people just tend to think it's a 32-bit float. It's not always. There are 2, there's 64. And actually in Go, a float 64 is a default float value for this variable. You can use them for complex numbers. And what I mean by that is real and imaginary numbers. And we're not going to dig too deep into that one because that's actually quite a difficult topic to explain and show. I mean, I've done quite a bit of it when programming, but it's a different story when trying to get that across to people. But on the face of it, complex number 64 or complex 64 is the equivalent to a float 32, and a complex 128 is the same as a float or equal to the variable value of a float 64. So 32 and 64 and 128 and 64. It's an odd one. The ranges that are on the screen as well. So on this slide, you can see the range for a float 32 or 32-bit is minus 3.4e plus 38, all the way across to the positive of that. So you got minus 3.4 to positive 3.4, and 64, float 64, sorry, is a minus 1.7e. So again, just a much wider range because you've got a little bit more memory to play with. And you can see how you assign them on the left-hand side. So you can also have a decimal, or you can have the IEEE 754 range, I believe it is, for a floating point number, which is 3.4e plus 38. And again, these are just used for high precision coding. I often use them when I am sort of working out exact measurements, maybe areas of places, or looking into times. So decimal places in time. That's always a really good use case. But besides that, more often than not, you just see it as a decimal place to 2 decimal places. So the top one, 123.78. So who can see what's wrong with this on the screen? Who can tell me in the chat? If you fancy it, just put it forward. You think, what kind of return are you going to get from this one? So in this bit of code, we are saying var x is a float 32 value, and it's equal to 3.4e plus 39. And I emphasize the 39 bit. And then I want to print that out. Is that going to run? Yes or no? Who thinks it's going to run? Throw it in the comments. I'm going to see if we've got anything there. So I'm seeing a lot of hello from, hello from Indonesia, Ohio. Wow, got an absolute, and Sweden. Global audience, loving it. Nope, no one's put in. Okay, so it's going to fail. It's going to error out. Now, errors because it's out of range at this point. So remember I said a float 32 value, that would have fit into maybe a float 64, but exactly an invalid input. And that's because the range for float 32 at 32 bits goes up to positive or positive 3.4e plus 38. Okay, and we put in plus 39. So you can see what happens when you run out of memory. So if you're not using the right float value, then it's going to automatically fail. Go is a typed language, and of course, and compiled. So it will do all of this before it tries to run the program. And obviously, if it can't compile it properly, or if there's not enough memory there, or memory values, it will completely cake it. It won't like it. It will fail. It will tell you that. And in this case, you use a float 64. So we are moving back to strings because I think I may have doubled up. I don't think, I think I may have messed up my slides a little bit, but that's fine. On the right-hand side, you can see strings are a read-only slice of bytes. Okay, so in Go, we like byte arrays. And I'm going to show you exactly why and how we like byte arrays when we go to the practical coding part. Essentially, everything is done at at that level. Okay, strings aren't written in Go as if a normal character would be. Okay, so character in Go is a rune. Okay, now a rune is basically an integer that represents a Unicode code point, so like underlying tables. And that's just too deep for this stream, but it is essentially not a character. So in a lot of other languages it is. In Go, it's not. It's seen as a Unicode code. And of course, they're all UTF-8 encoding. So if you've got the ASCII table up, it's kind of very similar to what you can have there. So moving on to array versus slices. Okay, so arrays and slices are really interesting in Go. And they're quite annoying because they're pretty much the same thing, but they're very different. Okay, so with an array, you can have a defined length. Okay, so length is, you tell it how many sort of indexes you're going to have. So whether it's like 1, 2, 3, or 4 indexes, and then you give it the data type, whether it's an integer or string. So maybe you'd have 3 lots or 3 indexes of a string value, and then you give the values. Okay, so you might be hello world Liam. Okay, 3 different strings. Or you can have an inferred length. Now, an inferred length in an array is defined by the compiler. Okay, and this is where it gets a little bit messy because slices are very similar. Okay, so an inferred length is defined by the compiler upon compile when you sort of run your code. And that is done by the ellipsis, which we spoke about a little bit in the previous episode, where you can kind of have a bit more dynamic play in your code with this, which is really good, but it can be quite dangerous if you end up with sticking like lots and lots of values in on compile. That's something you don't really want your program to be doing on compile time. You'd probably want to define that up front. There are cases when you would want this, but mostly often I don't see this happen. I see either defined length for an array or a slice. And of course, I have really messed up my slides a little bit, but it's fine. A slice. And a slice name, so a slice, you'd have a dynamic length at this point. Okay. Now, this is where it gets a little bit confusing because what you typically see is just a blank square brackets, as we can see here at the bottom. And then you have your data type and the values. Now, this just means it's really dynamic. You can grow or shrink as you need it to throughout the program. And I'm going to show you how this all works with a bit of code. So let's look at array known length. So in here, we can see that number 3 and the values, or the length of it is, or the values are 3 lots of them. And then in array 2, you can see the semicolon and the equals is the other way of initiating a variable in Go. But here we're looking at 3 and 3 lots. So you get 1, 2, 3, 4, 5, 6, 7, 8 as the output from this program. Now, if it's an inferred length, still the same output, but a different way of compiling the code. So we've got the ellipsis. So we're saying it's going to be an imaginary and unknown inferred length that's going to be put in there. And it's going to be 1, 2, and 3 that we're going to pass it in, and it's going to hold that value. Okay. So the same is spat out at the end, 1, 2, 3, 4, 5, 6, 7, 8, just through an inferred length. So that's the 2 ways that you can play with arrays in Go. And it's really, really good because it allows you to be a little bit more dynamic with something which is more so quite rigid, is probably a good word to say, because it's usually defined. It's like a defined amount of memory in your program, which you should be giving up front, but it makes it a little bit more dynamic using inferred length. Again, use that with the ellipsis. So what about a slice? Now, a slice is actually a reference to a contiguous segment of an array. So you can make a slice out of an array, okay? And it gets confusing at this point, but I see slices are a lot more common in Go code than I see arrays, purely because they are a lot more dynamic and a little bit more friendlier to work with. So you can see here on the left-hand side, say my slice, number 1, is equal to square brackets, an integer slice with no value. So automatically it's going to be 0. Okay, it's going to start off at 0. And the output of that is going to be, as you'd expect, 0. Now, number 2, my slice number 2 is going to be a dynamic length. So this is going to be a slice of strings, and it's going to say go slice are powerful, which they are. They're probably one of the most powerful data types that you can use, most dynamic, most playable, user-friendly. And the output of that is going to be go slices are powerful. But if you took powerful away, you can change it up. They're mutable, whereas arrays aren't. Okay, so like I said, you can create a slice from an array. They grow and shrink as needed, and you can make a function on them. And what I mean by that, the make is a keyword in Go, where it will create something for you. Okay, we're not going to look at that this episode, probably do it in the next one. But just bear that one in mind. So you can use make on them, whereas in arrays, you can't. Okay. So then we've got 2 other functions that we can use, and you can use this on arrays as well, but I see this more often with slices, where you got the len and cap. Okay, so len is the length of the slice, and cap is the capacity. Okay, so to everybody else, this may sound the same, but length is the current number of elements in your slice, and the capacity is the number of which it can grow or shrink by. So it's a little bit different. It's just in the way you say it. But if I were to get these, and if I was to print these values out, the very first one would be 0 and 0. And for my slice 2 would be 4 and 4, because you've got 4 there. So it can shrink by 4, or it can grow by another 4, and so on. Okay, so if there was 5 elements in there, it would be able to grow by 5. You know, it can double, it can shrink, it can go. It's pretty dynamic and really, really good. Next, we've got maps. Maps are another really, really powerful part in Go. Now, JSON is not friendly to use in Go, and it's notorious for that, but it's fine. And it's because you need to have more of an understanding of the underlying semantics. So when you're using buffers, when you're looking at memory, when you're looking at unmarshalling, for example. And again, I'm going to show you how to do that in the practical side of this. But look at this code, okay? We have got variable A, and we're going to make a map out of it, and that's going to be a string, and it's going to hold lots of strings, okay? So in here, we have got brand Ford, we've got model Mustang, we've got year 1964. And B, we have another map, okay? But this map is going to be of integers and strings. So we've got Oslo, 1. We've got Bergen, 2. We've got Trondheim, 3. And Stavanger, I can't even say that one, 4. So the output of that is going to be brand Ford, model Mustang, year 1964, key value pairs. This is a really, really nice way to play with key value pairs in Go. Okay, they're unordered and they're changeable. So you can play with them. They grow, they shrink. You can do what you like. Very similar to slices. As you can see, the declaration is actually very similar to a slice or an array. Okay, but really key thing in this, does not allow for duplicates. You can't have any duplicate values in a map. It will automatically eliminate them or error, one or the other. Okay, and when you initiate it, if we were not to put any values in this and just say var a map blank and blank, it would automatically by default just to be declared as nil. So it wouldn't take up any memory at all. It's just nil. A simple like 1 or 0 in terms of binary. Just to tell you not to use any memory, not to do anything like that. Another really powerful part of this is that it holds the references to the underlying hash tables. So when you're thinking about matching up data, when you're thinking about manipulating it and playing with it, maps are a really, really good way to hold data and reference hash tables. And that, again, will come into play with pointers and references and memory locations. Again, that's episode number 4. That's all part of memory management. And again, you can use the make function on maps as well. So we'll touch on that later, but a really, really good thing to note. So who can tell me if there's anything weird about the output of the code on the screen at the moment? And let me just quickly go to the Comments. Can we use any instead of ellipsis? No. Ellipsis is similar to any, but when you're declaring the unknown sort of length in a slice or sorry, an array, you wouldn't use any, you'd use the ellipsis. But back to my question. Anybody tell me anything weird about what I've declared in the function and what the output has come at? I'll give you a clue. If you look at the order, there's something weird about the order in the output of the second one. Oslo and Bergen have been switched around. And that is because, I believe, if I'm not correct, it is because it is alphabetical order. Spit my words out. So they switch around. Okay, so it orders them itself. That's just done by default, not done by me. It's just, yeah, exactly. So ordering. Cool. That's a really, really good one. Okay, so next, and I think finally, before we get into some coding, we're going to look at some structs. Okay, so structs are probably the backbone to Go. Okay, they're really quite complicated to understand at times, but they are essentially everything you need to know or want to be playing with data and ordering data and manipulating it. You probably need to use a struct. Okay, so if we look at this on the left-hand side, struct name, so you give it a name, you then declare it as a struct, as a type, so it's a data type, or sort of, yep. On the left-hand side, you say member, or not necessarily member, but you'd have like an index, and then you give it the data type, index, data type, index, data type, okay? So if we look on the right-hand side, we've got person is the struct, and that person is going to have a name, that person is going to have an age, that person may or may not have a job, and they may or may not have a salary, okay? Now, what it's doing is it's making attributations or attributing metadata to a certain parent, okay? So in Go, there's no inheritance. There's no classes, and it's done deliberately to keep it a lean language. And we kind of spoke about that in the first episode, but this is how you kind of get around that by building your own tables of information. So if I come out of here, I go to this link, and I believe it's over here. If we go into Go Playground, we can see how this works. Let me scroll down, so that's a big text box. Hopefully you can all see that one okay. So we can see we're importing the FMT package. We have the type person struct. They've got a name, an age, a job, and a salary. And let's say we've got two people, okay? Because there's not one person. People are unique. They have one version each. So we've got var1 or person 1 and person 2. So person 1, I'm going to say is Liam. He's 27. He's a software engineer, and his salary is 1, 2, 3, 4. Admittedly, I'd love a bit more. And then we've got person 2, Joe. He's 35. He works in sales, and he has a salary of 4,500. Okay, cool. He's doing well. So if we have to print these out, so let's say we're going to print out person 1 information. So let's print out my information in each different lines, and then we're going to print out person 2 information. So we're going to print out their name, age, job, and salary each. Okay, so let's run that and see what we get. We can see down here, it has printed out the key value pairs from that struct. So Liam, 27, software engineer, salary. Joe, 35, sales, salary. And that's it. So that's a really, really good way to work with structs and data. And we're using the dot notation, which if you're coming from JavaScript, is a really, really familiar sort of notation. I haven't personally used Python or any of the others to a degree of knowing this, but it may also be in those languages as well. But this is a really, really good way to play with dot notation and get different metadata out of certain elements that you create yourself. So I could create another one and call it animal, and the animal may have a name, it may have a color, it may be a dog or a cat or a certain type of animal, and that's where you then specify and work within your data. And again, I'm going to show you that in the practical side of this as well. So let's get into the code. Okay, now I've got an API which is going to give us all of the Pokemon names that we want. Okay, so there's all the information about Pokemon that you could possibly want, of all the cards, of all the little characters. And you can see on the left-hand side, there's a big JSON object. And it's got a name, it's got URL, it's got a, I don't know, maybe I have a picture or something in there, it'll tell you a species name. And then I've gone and dug into it a little bit further. And I've gone to one of the URLs of one of the Pokemons, and I have captured all of its information. So again, the left-hand side is everybody or every single character. On the right-hand side is just a single character's attributes. Okay, so it'll have its happiness, its capture rate, its color, the URL for all the other things that's going on. And I'll show you that in a browser as well. But what we really want to do, and what I want to personally do, is get all the names of these Pokemons. I don't care about anything else. I just want the names. Okay, so let's jump out and let's go and find, and let's go code something. So, like I said, the API is here. I'm not going to bother zooming in. I don't want you to read any of this. This is just all the different entries. You can kind of see it's in order from sort of here onwards. So you've got 2, 4, 6, 8, 10, and I'm sure there's other ones in line. But this goes all the way down to 150. Okay, there may even be a couple more at the end there that I'm missing. Okay, and I've gone to one of the URLs, no idea which one it was, and I've found it. So the Pokemon species 92. And that's where I got the information from the slides. Now we can see the base happiness, we can see its capture rate, and all this lovely information in all the different languages that you could possibly want. Okay, so you got, I'm sure there's maybe Japanese or Chinese or something else down here, just different languages. All I care about is the names of each of these. I don't care about anything else, just the names. So let's go and code. First of all, before I do this, do I have any questions in the chat? So we have got, how well can you use Goland in Microsoft Azure? Okay, so first of all, Goland is a IDE, really, really cool. And it's specifically built for Go development. I am unsure of how well it sort of works with Azure. I mean, I personally wouldn't want to use that. I would just go straight for VS Code. That's just my own personal opinion, not because I work at Microsoft, but because it has a really, really good Go plugin. It has a really good plugin on the marketplace for Azure. It's literally seamless. So I wouldn't want to use anything else. You can sort of deploy your services straight from your VS Code window. I've showed how to do that in previous episodes, but I do have a blog coming out in January to show you how to do a load of other stuff, but that is part of it. So yes, 100%. If you want to use Goland, that's your personal preference. It does tie in, I'm pretty sure. It's got a really good Go plugin. I just use VS Code. What else do we have? Okay, so there's no other questions. If you have any questions, please do throw them in the chat. Ask away. I'll be happy to answer them as best I can. So yeah, let's go and code. So over here, some of you may remember from last time, we have a web server. Okay, and that web server, we made a maths package where we were returning and adding some numbers, and we tested that as well. So we wrote a couple of tests. There's some table testing. If this isn't big enough on the screen, please do let me know. Just fire away in the chat. Ask me to zoom in. I hope you can see it okay. It looks all right on my screen. So yeah, we did some table testing to add some tests in. It ran through. We did some benchmarking, so some performance analysis. Again, if you missed this, please do go back and watch the other episode and go see what we did there. And if I ran this test, or if I ran this server, so let's just go run main.go. And I was to curl the root, the home root, which is here. So this handler function. So let's curl localhost :8080. Should see the sum of the numbers is 6. And that is because in the home function that I have written, and I wrote in the last episode, we were throwing in a couple of numbers. So we're adding 2 and 4 together and then converting it to a string and then throwing that string out. Okay, so it was going away. It was calling this maths function, adding X and Y, basically the 2 parameters I'm passing into the function, and it's going to return it to me. So that was part of last week's episode. So ignore that, but we do have a server running. So just remember, we got the server running. So let's clear these terminals. Let's cancel this one and clear it. What we want to do is write another API route to call this API for the Pokemon names and get back all our data. So what do we first want to do? We want to make the API GET request. Okay, so with a GET request, they're all pretty standard in Go. I'm just going to copy and paste it over. It'd just be a little bit easier to do that than try and type and talk and try and explain at the same time. Ignore the fact we've got some red lines. It's fine. We'll print this out in a minute. But we're saying response and error is equal to HTTP GET, and we're going to call this API, which is the same URL that I just showed you in the browser, returning all of that information. And then we're saying if there's an error, then print the error and exit. Okay, so I want it to just jump out and stop what it's doing if there's a problem. So what do you think will happen if we print this out? So if I do an fmt.println and then we put in response, that red line is going to go away. And now we can see all the data which is going to be returned if I ran this server. So let's go ahead and run that. So let's do go run main.go. Okay, so I'm going to start the server up again, and I'm going to curl the API root, and I'm going to put /API at the end from this handler function to call this function that we're calling now. So what happens on the left-hand side? Whoa, loads of data, and not necessarily the data I want either. So this here is, oh, you can see, cheating. You can see this is all the headers. This is just the return response at the very, very high level. So it's saying that it worked. It was a 200, which is fabulous. I'm glad it worked. And it's created a map for me. And this map has got all the different key value pairs that it could possibly want to tell me. And there's one thing that I care about most in this response, and it is a content type, because it's telling me that I get back application/JSON. Perfect. Now I know what I'm dealing with. That could come back and say plain text. It could come back and say XML. It could come back and say a whole bunch of things. But I'm glad it's JSON, because that means now I know what I'm working with. So we can go through this line by line. So let's cancel the server. Let's clear that one again. And let's move this out of the way. Now we got response. Now we want to read the body of that response, because we don't care about all the other fluff. We just want to read the big main bulk of data inside that response, don't we? So what do? Let's get rid of this print line for starters, because we don't want it. But what I am going to do is I'm going to say response data. So again, kind of making another function call at this point. So response data and error. And the reason I've got two variables outside, I'm going to explain this in the previous episode, but I can have two variables because it's going to return two values. Okay, we can see here, it returns a byte slice and an error. And much like this get returns a response, so HTTP response and an error. Okay, so it can take in a string, which is the string that we're passing through for the API, the HTTP, HTTPS URL, and it's going to return a response and an error for me. So that's why I've got two. I could equally just put like an underscore, and it would completely ignore the error return value. But then if it does throw an error, I wouldn't be able to catch it or no. So that's not a good practice. So we're going to read the body of the response. And what we're doing saying is response data and error is equal to ioutil.readAll. Now that's readAll function is just going to read everything until the end of a file from the body that we're getting. So it's going to read everything right up until that last line. And it's going to be response.body. Now the response is here. Okay, so it's from our request that we assigned it a variable. It's our request. Now let's go and print that out. Now let's do response data. Okay, what do you think we're going to get back from this one? Bearing in mind, it's going to be throwing back a byte array. Anybody kind of guess what that would look like? You know, about maybe 20 seconds until I press go. But I'll tell you what, I'll zoom in a little bit more. Sorry about that. I only just saw that message. Let's move this out of the way. And hopefully you can see that better. Hopefully that's better, yeah? So let's go and start this server up again. Okay, so go run main.go. So that started. Now let's curl that same API. Whoa, again, not what we want to see, but it's good because this is now the next layer of abstraction. We've made the request. We've figured out it's JSON. We have gone into the body. So now we're in the body of the response. And now it's printed out the byte array. So it's good. It's telling me there's loads and loads of data there, which is brilliant. And that's what I want to see. I want to see all these numbers, but really that's an awful lot of don't really want this, right? But now I know what I need to do. Now I know there's data. I can unmarshal it. I can play with it. I can figure out how to get this into a readable format. So again, let's clear that and go back to the drawing board. Okay. So we have got the response. We know there's data that I can play with. Now I need to unmarshal that JSON. Okay. And I think it's spelled like that, unmarshal. Yep. Typo. So what do I want to do to unmarshal it? Now this is where Go has a bit of an awkwardness around it, and it's not always easy to play with it, but that's good because it's a learning curve for me. and for you. Okay. Now this always trips me up every time I'm playing with JSON. I always end up Googling how do you unmarshal. It's a bit frantic, but it's actually really quite simple, and you can do it in like 1 line of code or 2 lines of code. Okay. Now those 2 lines of code looks like this. Okay, and this is where we're going to have some red lines, and this is where we're going to take you through the struct. Okay, so we're saying the variable response object, okay, which is of type response. Okay, now response isn't necessarily a type of data, but I'm going to make it a type of data by assigning it to a struct. And then once I have that struct, I'm then going to unmarshal, which is a keyword in Go. So JSON.unmarshal. And I'm going to unmarshal the response data and into the response object. Okay, so this response data over here, so this byte array is going to be sort of plumbed into response object, which is of type response, which again is a struct, which I'm going to show you. So it's taking all that byte data and putting it into a different place. Okay, so why do we have a red line? Saying we don't have a response. I know we don't have a response because we don't have a struct to put this data into. So let's zoom up a little bit. Let's move this down. This might get a little bit awkward with spacing on my screen, but we want to look at response. Okay, so we've made a struct over here, which is response. So it's saying type response is a struct, and it's going to have a name, which is of string, and that is going to equate to the JSON equivalent of name. So in the data, let's go back over here. We have, I appreciate this is really, really bad to look at on your screen, but let me zoom in a little bit. Hopefully you can see that. We have name in the JSON object, okay? And we also have Pokemon entries in there as well. So in that JSON object, somewhere in there is Pokemon underscore entries, okay? And that is going to be the equivalent of Pokemon. But that's also going to be a struct because we have to go down these different layers because it's different elements of a JSON object. So imagine you've got that top layer, you've then got another layer, you've then got another layer, and it's exactly the same thing, just with structs. So we're going to create another struct called Pokemon. Now that Pokemon, or that struct, is going to have an entry number, which is an integer, okay? So it's a signed integer, again, just determined by my system, 32 or 64 bytes, whatever it feels, or bits, sorry. And it's going to be the equivalent, it's going to map it to entry in the JSON object of the data which I'm grabbing. Likewise with species Pokemon. So, sorry, species Pokemon species. Again, I need to make another struct for the species itself. Okay, so we just see we're going down in layers, we're attributing and mapping to the different parts of the data. So let me undo this one as well. And down here, we've just got our final struct, which is going to be name, because all I care about is name. That's all I want to print out. That's what I have. Okay, so you come down quite a few layers, but this is how you do it in Go. And it makes you think about the kind of data that you're pulling in, making sure you don't pull in any extra data that you don't need, and keeps it really quite nice and lean. So let's go down to our call API function. And in here, we are going to print that out. Okay, so we can see we've got rid of that red line for response. Now I can print out response object, and let me see what I get out. Do F and key line, and then we do response object, which is this one here. Hopefully it doesn't error. Perfect, it doesn't. And now let's run that server one last time before we go on to the next step. So that's now running. And I want to curl my local host. Let me just skim up a little bit. We're going to see, amazing. Okay, cool. Now I can see the different elements within the JSON which have been mapped. We can see their names, and that's it. What more could I want? Well, actually, there is a little bit more that I do want. I don't want any of this jargon around. I don't want these curly braces. I don't want the square braces. I don't want the numbers. I just want their names. And there's a really cool, simple little way we can do this. And we can do it with a for loop. Okay. So go back to the drawing board. We remove the print line. And we're going to loop over the data of each index inside that for loop. And we're going to print it out. And it's really quite simple to do. And you'll also see a comment in here. So what this is doing is saying for I is 0. So very, very similar to any other for loop you've written. You got the length of the response object .pokemon. So that's referring to the Pokemon struct itself. So not the overall one, but the one that's that we assigned to Pokemon. And it's just going to iterate over and over again, printing out the name. All I care about is the response object, Pokemon I species dot name. So you can sum down these different elements through the dot notation now, and you can see how I've managed to get different parts of the data just by using that. And again, we can ignore this line here. This is a slice, which I was going to show you, but I don't think we're going to have time. But that is how we can print out all the names. You ready? Let's play it. Let's run this server one final time to show you that all we can get out of this is the names through just a for loop. Ta-da! Now we have the names. I can do whatever I want with them. I can put them into a table. I can assign pictures to them. I can create a website. I can do a search bar on them. So as you can see, I've gone through lots of different elements of the data. So we started out with something that looked really messy and horrible that looked like this, and turned it into a simple return value or a lovely list of names. So we got Bulbasaur, we got Ivysaur, we got Venusaur, we got Charmander. I'm not really into Pokemon, but I thought this is a really cool way and fun way to show you how to play with structs and how you can have different levels of structs, because it's all good showing you a person. But what happens when you want to make a struct within a struct? So it's nesting. So this is a really good way to sort of demonstrate that when you have lots of different layers of JSON data, that you can have nested structs. You can have different ways to manipulate that data. So I can put it into a Pokemon slice and I could append it and I could start printing it out. So again, if I wanted to create my own sort of data types within this, I could quite simply, I could append it. I can make an array because I know there's 150 Pokemons in this list. I could do all sorts of things. But this is, a really good way to sort of play with an API and understand how to work with different bits of data just by using different structs, as we can see here. So all we did was 3 structs, called a bit of data, got the response, and plugged in the response body into our own struct, our own manipulation. So I got rid of all the jargon that I didn't really want in that data. And that was like a really good thing for me to want to play with this further. So hopefully that was useful for you and a really good way to sort of see that. But let's go back to the slides, because I think we're reaching 46 minutes, 47 minutes, almost at the 50-minute mark. I want to answer any questions anybody has. So what's next? What's coming up in the next couple of days? So luckily for you, I am back tomorrow. I'm on screen with my colleague Carlotta. She is over in Italy, and we're going to be starting a new series called Getting Practical with ML.NET. Okay, we've got a 3-part series. We're going to take you all the way through the basics to setting up your dev environment, to using Model Builder, to using sort of the applications that you use in Visual Studio, or she will, because I'm on a Mac and unfortunately some of the things don't work on my machine. But that's going to be a really, really cool one to get involved in as well. So if you're around tomorrow, if you fancy having a little mooch of that one, then please do join in. Hopefully I'll be feeling a bit better and my voice won't be as croaky tomorrow, but we'll see. But we're kicking it off, getting started with ML.NET tomorrow at 4:30 p.m. GMT. Hope to see you there. And unfortunately, I have some bad news to go along with that. I've had to reschedule my final one, which was supposed to be happening on the 14th of December. I need to push it to the 25th of January. Now, that is because I am going to be speaking at a conference at the same time as my event was scheduled for. And unfortunately, it's also not in the UK. So I'll be abroad, and the timings, unfortunately, just didn't fit in. I tried so hard to do it. But I've rescheduled it for the 25th of January. I will be sending an email out to notify everybody who is signed up on this one through the Microsoft Reactor website or meetup. I'll let you all know. I apologize, but I will come back with a big and better bang, because I'm going to be following up this series with a continuation, whether it is every 2 weeks or every 3 weeks, where I'm going to be going through Stack Overflow, different forums. I'm going to be looking at the hot questions that people are asking in Go and showing you how to solve them in real life. I'm going to be going through it, functions, all sorts of things. So JSON and XML is always a popular one. So I thought I would tackle that one in today's stream. But I'm going to be doing a Learn Go with Liam. I'm going to be bringing on guest speakers from different organizations, from Microsoft or different companies as well, from around the globe. And hopefully, if you're interested, I'll get you on live stream with me and we can go through something together. So please do get in contact with me. My handle is somewhere down there. So if you want to ping me on social media, my DMs are always open. And you can contact me on Twitter or TikTok if you want to. And my GitHub handle is all the same. And of course, if you want LinkedIn, it is just /Liam Conroy Hampton. And that's my Cloud Skills Challenge. So please do give it a go. You can tackle everything which I've done today within there. You can get a little bit more reading around the different data types, around the different structures. And yeah, if anybody's got any questions, please do fire it in the chat. I apologize for not being so upbeat today. Hopefully I'll be back to my normal self in my next episodes. But yeah, if you do have any questions, please throw them in. And yeah, I see a lot of zoom in. I see Goland. There's no other questions in there. Was there any more questions? I'm going to take the silence as maybe a no. Hopefully. If you have anything, throw it in. Now's your chance. We have all of 7 minutes to go through this. Okay, I'll take that as a no. So thank you ever so much for joining today. I really appreciate it. It's always good fun to be playing with Go. It's as an engineer, it's something which I really enjoy. And hopefully you learned something today. And yeah, I will see you tomorrow if you join in the ML.NET series. If not, I will see you on the 25th of January with my new series. Or if you're in London, pop along to the Microsoft Reactor and come in and see me when I'm better. Thanks all. Bye-bye now.